Hey peeps, welcome back to another math vid. Today we're going to be looking at some slightly more complicated questions, also involving geometric shapes. So our first question today is use the figure to answer the question. And you can kind of see here that this is like your childhood nightmare. Like when you first saw this question, it's like, wait, how does this work? And our question today is how many squares can be found on the figure above? Still straight out of nightmare. But instead of going the classic method like, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. It's like 1, 2, oh wait, oh yeah, I forgot 1, 3, 4, oh no, I'm confused. So instead of going like that, there is actually a strategy for this as well. Instead of going like that, you can mark these boxes here. This is grid 1, 2, 3, 4, and 5. This is grid 1, 2, and 3. And I will prove this strategy after I show you guys it. So by looking at this, you match the biggest with the biggest, the second biggest with the second biggest, and the third biggest with the other biggest. And these remaining two, they just don't matter anymore. So using this strategy, you multiply 5 and 3, 15, 4 and 2, 8, and 3 and 1, 3. And adding those all together will get your answer, which is, by looking at that, so these two are 11, 11 plus 15, 26. So our answer here is 26. But why is our answer 26? Why does this strategy work? Speaking of that, remember the question I showed you in the very, very, very beginning, where it was just like, oh yeah, I forgot one, oh no. But that also kind of implies to that. So let's bring our grids back. And looking at this figure here, you can see that first strategy, it was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, or just 5 times 3. And 15 is the exact same as I just said, 5 times 3. So 15. And do you see that right there? It actually does work like that. And to make sure, let's look at 4 and 2 as well. So here we've got 1, 2, 3, 4, and we've also got 4 on the bottom. So then we've got 4 times 2. So doesn't that kind of, it's starting to make sense now, isn't it? So that means, yes, it does work. Just put all your numbers together afterward, and you won't be sorry because you're going to save quite a bit of time. Not just quite a bit, actually a lot a bit. So moving on to the next one. This one kind of follows the same logic. Use the figure to answer the question. How many rectangles in the figure below are similar to the ones above? Basically this thing. So there is actually a solving method for how many any rectangles are in this shape, but these are looking for the similar ones. So instead of using that one, which I'll talk about in a later video, we're going to use the same one we used for number 1 here, good old number 1. So speaking of number 1, do you still remember the strategy, which I just explained about 5 seconds ago? So we've got a grid 1, 2, 3, and 4, and 1, 2, 3. So 4 times 3, 3 times 2, and 2 times 1. And we can just not care about that one for now. So we've got 12 plus 6 plus 2, which would get our final answer, which is 20. But why is that answer 20? Proving again. So looking at that, it's about the same proof as the first one, where you see here there's just like 1, 3, and 4. So that would still be 12. And yeah, it all works the same. It works, and it's going to save you a lot of time, and you're going to be grateful, and you're going to be happy, and you're going to be very, very, very happy, and you're probably going to get them all right, because doing that way is very confusing, and you might leave out a few, and then you're not going to get that question right. So I hope this video helped you guys learn at least a bit more about math, and I'll see you guys in the next one. Bye!